What I would suggest is anyone who is really interested in solar power technology as a whole, in fact the entire gamut of what goes on in the solar technology, I would strongly recommend that in lieu of sitting and just getting primed on solar power physics, that you attempt to really take a lecture course in solar power technology. I usually conduct quite a few of them. And that way you really would be totally familiarized with the entire aspect of physics, manufacturing, technology, applications, because when it comes to applications, we have such a diversity in terms of solar power applications that ranges from architectural to heavy grid-connected power systems. In this instance, what we are showing is the p-n junction material that is sitting here, and the solar rays or sunlight or photons are impacting the junction, and it creates the flow of electrons. So you could even look at the solar power cell as being a tiny little battery. It only operates when there's a solar ray hitting it. In other words, what we're really talking about is a filter, if you wish, that captures the photon and uses the energy of the photon to cross over electrons from one level to the other, thus creating a circuit. Now, there are quite a number of technologies which are based on this technology. One of them happens to be the transistor. In fact, solar power cells came about at the same time when the transistor was invented in around 1956 by Shockley and Bartin, and it changed the world that we know today, because everything that you touch is based on that p-n junction that I just discussed. Photovoltaic technologies, when we are talking nowadays, mostly they're based on silicon technologies. I would say about 90% of them. And there are also other solar power technologies that do not use silicon. They use all sorts of other types of materials to form some sort of electron transfer system. I would not be concentrating on that. They fall into categories of nanosolar technology, synthesized technology, film technologies, and so forth. Here what we see is a raw silicon that is harvested from a mine. Usually the process involves silicon, as you know, is just a glass or a sand, except when you look at the sand, it has a lot of impurities in it. It has iodine, calcium, and so forth. In order to be able to really construct a solar power type of material, you really have to remove all of those impurities from it. And the way to do it, there are several of them. One of them is called the Tchaikovsky method, where you really melt the silicon that is taken from a mine, and you go through a process where the process involves like making a candy. You put a silicon at a molten silicon, shall we say, raw silicon soup, and you rotate it. And after a while, the pure silicon collects around it. Another one is a gasification technology through an arc furnace, where you vaporize the silicon, and you, through centrifuge, you collect the pure silicon, and so forth. Since we're supposed to be talking about generalities, I think this should suffice to let you know that the majority of the cost of producing shall we say, solar power modules is the cost of silicon purification. Silicon, when it is purified, then it goes through a number of processes to produce solar cells. This is one of those chambers that the graphics I showed before. These chambers, what they do, they really take the silicon, they melt it, they go through this spinning process, and then you get ingots. The ingots that come out, they're taken, they're sliced through diamond saws. They produce very tiny wafers, and the wafers are etched. Etching is a process that some of you may be familiar with. It's a chemical process and vaporization process where you really create channels to deposit these doping materials, N and P. Then you stack them together to create the PN junction. As I said, the solar junction itself is like a tiny little battery, and if you connect them together, they have a certain characteristic voltage when you put two PN junctions together, depending on the material and the junction surface and so forth and the type of impurity. When you're impinging a solar photon on it, it creates a flow of electrons, but the amount of electrons that are being generated depend very, very much on the type of material, the etching, and the process. And as I'll show you later, this PN junction technology that we've been looking at here is more or less the standard in producing conventional flat plate photovoltaic system. This is just a cross-cut of a regular solar power frame, where it shows, various components of solar power photovoltaic panel when you buy it from for installation. Inside of a solar power module looks something like the following. These are solar power cells. They're little batteries. They're hooked up together. Eventually, a group of them form a solar photovoltaic panel. And if you've seen solar photovoltaic panel, you will see these blocks of either square or hexagon modules. They're all soldered together. At the end, what you're getting is a plus and minus potential. And essentially what you've got is a microcosm of tiny little batteries. When all of them get activated, you really have a flow of current. So essentially this is the skeleton or the anatomy of a solar photovoltaic module. Then in construction what we do, we really take this group of, or subsets of groups of solar modules, we connect them together to generate larger amount of current, and depending whether you connect them in parallel or in series, you could generate all types of voltages and currents. Now, this is more or less the very basic of solar power systems. This shows the manufacturing facility where these units that you see here, they're the combination of those microcosm of tiny little cells that have been etched and they are welded together. So after putting the solar cells together, they're welded, they're put into frames by a robotic system, and eventually you end up, I'm not going to go through this, these are other types of technologies. Then eventually what you get, there are solar panels, let's say, of like this panel here. And essentially, by hooking up the solar power together, what we do, we generate a certain amount of DC power. Power output, by the way, from solar cells is DC, direct current.